Hello, welcome to Mat-073. My name is Rob Reynolds, and today we're going to look at section 2.4, linear functions, and specifically looking at their graphs and how to determine slopes. So the general form of a line is y equals mx plus b. Remember, y is the same thing as f of x, so sometimes we'll write f of x is equal to y. So you can put in a term. If you see an ordered pair x comma y, sometimes it's written x comma f of x because that f of x is that y value. So today we're going to look at, if I give you 2 points, how to write the equation in slope-intercept form. And slope-intercept form is y equals mx plus b. And then we're going to look at some word problems as well. So first of all, a linear function, anytime it's x to the first, it's going to be a linear function. I think I've discussed y equals x, it's going to increase. By the way, if I do negative x, we're going to learn today that it's not increasing, it's decreasing. And you read a line like you read a book from left to right. So if it's going up, it's a positive slope. If it's going down, it's negative slope. And you know a couple others, hopefully by now. This is a quadratic, parabolic function. Maybe you've even seen x cubes, which graphs these nice S shapes. I think we've discussed absolute values, which value is spelled with a V, and it kind of looks like a V. And we might even have looked at reciprocal functions. 1 over x, where it does this hyperbolic function. So you should start getting used to looking at the different types of functions. I don't think we've looked at square root functions yet, but we will. So you should know some general shapes of some graphs. Well, today we're just going to focus in on linear functions, so everything should be x to the first power. So here it is, 3x. So you could rewrite this y equals 3x plus 0. Today's lesson we're going to be looking at graphing using slope and y-intercept. So if the y-intercept is the last value, b, is the y-intercept, and that's kind of a start value. That's where I'd like you to start graphing the function. So if the y-intercept is, here's the y-axis, so that's where the line crosses the y-intercept, is at 0. And this is your slope, and today we're going to learn that your slope is really defined as rise over run. So 3 is the same thing as 3 divided by 1, so I could rise 1, 2, 3 and run 1. And I could try to do it again, but I'm a little bit off my graph. Instead of going up and to the right, I could go down and to the left. So I would recommend you fill up your graph and then grab your student ID or a credit card and see if you can't just graph that nice straight line. So that's for y equals 3x. We could repeat this process for the next line, and I'll change colors here. So y equals 3x plus 2. Remember, you could always do a t-chart if you didn't like this method. I'm not a big fan of the t-charts. You could plug in like -2, -1, 0, 1, and 2. Plug in for x, solve for y, and actually look at what the y values are. I'll do 1 or 2 here, but I think graphing y equals mx plus b, slope and intercept, is much faster. But if you were to do the t-chart, we could go 3 times -2, which is -6, plus 2, which is -4. So that gives me the point -2, -4. If you plug in a -1, that's -3 plus 2, which is -1, or the point is -1, -1. If you plug in a 0, the y value will give me 2. So I could continue in this fashion. So let's see, 0, 2, -1, -1 is down here. -2, -4. I hope I graphed that correctly. Let's find out. So y equals 3x plus 2. This is my y-intercept, so this is a start value. And it looks like at least I got that part right. So there's my start value at 0, 2. So that's called the y-intercept. And the y-intercept is always going to be 0, comma, some number for the y-intercept. This is my slope, which means rise 3, run 1. So 1, 2, 3 over 1. There's a point. Down 3 over 1. Down 3 over 1. Looks like I got my points pretty good. Looks like my graph might be slightly off because my straight edge is not very straight, evidently. But if I were to graph this line as well, it looks something like this. Oh, I'm off a little, you can see. Okay, so I think the author did a little bit better job graphing it. So there's the y-intercept. At 0, 2, and the rise 3, run 1. And the important thing here is to see that the slope here is 3, the slope here is 3, and that forms two lines that are parallel. And parallel is sometimes used with this symbol. So if you see that symbol, sometimes that represents parallel lines. Later on, we're going to talk about perpendicular lines, which form a right angle in here. And parallel lines have the same slope. So that's what's happening. Notice we have different y-intercepts. This y-intercept was a 2 crossing here, but this y-intercept was a 0. So that's what they want you to see. The y-intercept is always some point y, 0 comma some number, in this case b, and m is going to stand for slope, and we're going to use the definition rise over run right now because I'm giving you a graph. Later on we're going to learn another definition of slope if I give you 2 points. So for each equation, find the y-intercept. Easy peasy, chicken cheesy, it's that last number. So 0 comma 7 is the y-intercept, and here would be 0 comma negative 9. As long as it's in that form, y equals mx plus b, I know that that very last number should be my y-intercept. Make sure you grab that negative sign when we're talking about a y-intercept. So 0, 7 and 0, negative 9. The slope of the line containing 2 points, yes, could be defined as rise over run, but could also be defined as change in y over change in x. So sometimes you're thinking, well, when should I use what definition? My recommendation is if I give you a graph, let's use the rise over run. If I give you 2 points, let's use y minus y over x minus x. So if you can just physically count the rise over run, that's going to be my slope on a graph. So here it goes. Graph the line, plot the points, and then find the slope. So this means 3 to the right and 2 down. Gives me this point. This says 7 right. Ooh, off my graph. And then 5 up. Sorry about that. I needed a different graph. But to find the slope, I would check out the rise over the run. So this is going to be rise 1, 2, 3, 4, 5, 6, 7, and run 1, 2, 3, I believe 4. But again, I'm off my graph, so that wasn't a very good image. Let's see if it works. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4. So there it is. Rise over run. So I would use rise over run for the graph. Here they're showing you that if you plot the 2 points, the second approach is we could take our y minus our y value, which they did here. They did our y sub 2 minus y sub 1. So they started with 5 minus a negative 2, and then they subtracted off the x's. And that's how they got 7 minus 3, using those blue numbers, and that's still 7 fourths. So given 2 points, we could always do the change of slope formula as well, y minus y over x minus x. So this is talking about if the line slants up, as you read a line from left to right, then it's positive slope. This is also positive slope, and then they talk about, well, which one's steeper? And the larger positive number is going to be the steeper slant. So this is obviously steeper because 10/3 is larger than 3/10. Here, these are negative slopes, both of them. You read a line like you read a book from left to right, and these are both going down. Which one's steeper? Well, this is still a larger absolute value, so I would stick with the same definition. So they say the smaller negative number, but I would stick with the larger absolute value because the absolute value of negative 10/3 is still 10/3, and 10/3 is larger than this absolute value, which is 3/10. So the larger value is still here, and this is steeper. So graph D is steeper than C, and graph B is steeper than graph A. So 2 things, wrapping up what we've learned, y equals mx plus b, and the slope is the m, and the y-intercept is the b term, or the last number. So determine slope in the y-intercept, Here's my slope, the number in front of x. Don't put the x with it, it's just the number in front of x. It's called the coefficient. And then the y-intercept here is usually an ordered pair, x comma y. So it's actually, you can actually plot a point. So I would say 0, -4, and 3/5 is the slope. If it's not given in slope-intercept form, it may be given in standard form, ax plus by equals c form. And the book is going to recommend that you solve this for y, which is really not my recommendation. But I'll show you how to do it the book method, and then I'll show you a shortcut method. To solve for y, we're going to have to get it all by itself, so I'm going to undo the subtraction and addition first, leaving me with 7y. I can't combine these, so leave it -4x plus 2, and then divide every term through by the leading coefficient of -7. So y will equal 4/7 x minus 2/7. So then I can see that the slope is 4/7, which is what they asked for. They didn't even ask for the y-intercept. Oh, yes they did. The y-intercept is 0, -2/7. Maybe an easier approach of this is to use a definition. Monkeys wouldn't prefer apples over bananas. If you know the values of a, b, and c, where this is my a term, is 4. This is my b term, which is -7. That's all I need for this definition of slope. So I would say monkeys wouldn't prefer this number, the first number, was -4, over the b term, which is -7. And that'll give me 4/7. And I think this method of finding slope is a little bit faster than actually spending the time to do all of this work of solving for y. Again, the definition, monkeys wouldn't prefer apples, that's the -a, over bananas. Monkeys wouldn't prefer apples over bananas. Find slope very quickly. If you'd like to find the y-intercept, my recommendation would be let x equal 0. And if you let x be 0 up here, 4 times 0 is 0, minus 7y equals 2, and then we divide through by -7, and y equals -2/7. Again, a lot less math than actually put it into y equals mx plus b form. So we can use the standard form of an equation. Again, that's ax plus by is equal to c. So if it's in standard form, to find slope, I would do monkeys wouldn't prefer apples over bananas, and to find the y-intercept, I would let x be 0. And it looks like the author did the same thing. The slope is 4/7. They took the time to solve for y. It's been my experience that students make more mathematical mistakes solving for y than they do using the definition monkeys wouldn't prefer apples over bananas. Sometimes slope is confused with grade. Grade is slope as a percent. So if I say 3% grade, that means 3 feet for every 100 feet. So, for example, maybe I'm going 3 feet down for every 1 feet over. Or after you travel 100 feet to the right, you've declined 3 feet. And that's a nice ratio, but you can put that out of a percent. So anytime you see the word grade, it's really just slope as a percent. So if they say, find the slope, and they say, or the grade, remember the grade is just the percent of the fraction. We can change any fraction. If they give you 1/2, you can change that to 0.5, which you can change that to 50%. So if I change it into a percentage, that's called your grade. So it's 50% grade is the same thing as slope of 1/2. So here, this slope is, again, rise over run. So the rise here would be 0.42. The run would be 5.5. You may want to ask yourself, is this positive slope or negative slope? And again, it kind of looks like it's a negative slope because it's declining. So, or you could say, well, it's positive grade because she's going up. So I'm not sure if the author's going to go here positive slope or negative slope. But if you read a line from left to right, this certainly looks negative. But since she's going this direction, my guess is it's probably going to be positive slope. So I would take a calculator and multiply 0.42 divided by 5.5, and I think that'll get you around 7.6%. And again, my guess is this is probably going to be positive because she's heading uphill. Yep, author chose. And they did a bunch of nice math, but I would just pull out your calculator and do 0.42 divided by 5.5. So here it says what rate can be determined from the graph. So I would look here on the ledgers. The y if I know that slope is change in y over change in x, then I want to talk about the y's first. And it looks like the y's is the number of haircuts, and it looks like the x's is the time of day. So I would say, to answer part A, I would say something about what's it determined from the graph. I can determine the number of haircuts per hour. Haircuts per hour. So then part B is saying, well, what is the number of haircuts per hour? And to do that, I would probably identify some points. This is 1, 2. This looks like it's 5, 10. And then I would probably use the y minus y as the over x minus x definition. I always like to start with the second point. It doesn't matter, though. Just be consistent. 10 minus the 2, that's the y minus the y, divided by the x values. So here comes the x's. I have to go back to the 5, so I cannot go 1 minus 5 now. You've got to go 5 minus 1 because you're always doing second point, point B minus point A. And in this case, we're going to get 8 over 4, which reduces to 2 haircuts for every 1 hour, reduced down. So 2 haircuts per hour looks like the rate. The last example talks about average education in 1993. I'm going to record this. Let's maybe write down the correct number here. In 1993, it looks like there was $14,500, and in 2011, the amount is much greater, $26,600. So my guess is they're going to say, well, what is the slope? What's the change in rate, which is another way to say it's slope. So find the rate of change, which whenever you see rate of change, that just means the slope. Rate of change is your change in y over change in x, and that's why they call it rate of change. So let's do it. Y minus y over x minus x. You could do 14,500 minus the 26,000, but again, I would recommend second point minus the first point. So there's my y minus y, and let's go back and grab the x's. So again, I'm doing point B minus point A. So I'll go back to point B x's, 2011 minus 1993. That gives me 12,100 divided by 18. I'd take out a calculator and maybe, since it's a word problem, they want to know the debt, so I wouldn't leave it like this. It's about $674 per every 1 year. So I'm trying to reduce this so it makes a little bit more sense. So don't leave it in terms of 18 years. Let's reduce this to per year. So recapping what we've learned, if I give you a graph, I would use the rise over the run definition. And remember, this is going to be a negative slope because it's going down from left to right. This is a positive slope because I'm moving up. This one down here, to find slope, I would not do rise over run. To find slope here, I would do y minus y over x minus x. And honestly, it doesn't matter if you do point A minus point B or point B minus point A. You'll get the exact same answer. My recommendation would be just stay consistent. So you could do 9 minus 5 over 6 minus 4, and that should be the same thing as 5 minus 9 over 4 minus 6. So I tried to switch. Here was point A minus point B, and here was point B minus point A. But you always have to put your y's over your x's, and you can remember that because the y's sound like the rise. They rhyme. So put the y's in the numerator and put the rise in the numerator. I hope this video was helpful. If you have any questions, feel free to email me.